So to continue our theme of components with variable values, this component close-up is all about adjustable resistors. I'm going to look at resistors which can vary their resistance, but not with a knob on the front like a volume control. These are all adjustable as part of an alignment procedure or maybe on the factory production line, so that they are used to adjust an internal adjustment to maybe null out component tolerances, maybe to set up internal voltages exactly where they need to be. It's something that was fairly common in the early days of electronics. Nowadays it's something that we try to design out adjustments. But still, we've got some interesting, I hope, adjustable resistors, adjustable potentiometers. Here's one. This is a very early example of a variable or adjustable resistor. If I put a screwdriver in there, you can see very clearly. Come on, twiddle. There it goes. There's the wiper going around the carbon track. So these are the two carbon track terminals. There's the wiper wiping around. On the other side, you can see there's the wiper terminal, the adjustment. You could have a hole in the printed circuit board and adjust it from this side if you wanted to. These are the two ends of the track. So it's very similar to a standard panel mounted knob adjustable pot, except there's only a screwdriver slot to adjust it with. And of course it's fairly big. These squares on the back here are 5mm. So this is a fairly big example of a variable resistor. They came in various different designs. Here's one that has a plastic, made in England, look at that, plastic, green plastic dial. So this is adjustable by turning it with your fingers. Now that might have been a bit hazardous because it might have been in a circuit which was at quite high voltages. This may have been part of a valve television or a valve radio. You might have been, getting a bit close to the terminals with that, but it's insulated, so you're okay, right? 500k ohms. There's also a slot for the screwdriver to go in there, so it's very similar to the earlier one. Simply has a plastic dial on it. Sometimes they'd even go as far as make a little slot in the chassis somewhere, and you'd simply adjust it through the slot, rather like an edge volume control. Okay, so that's another fairly big one. That's another moderately large, although it's slightly smaller. What have we got here? 100 ohm linear. More enclosed, so this one protects the carbon track a little bit. So although you can twiddle it in the same way, bit of a plastic cap over it to protect the carbon track. Not a bad idea, I think. That's quite a nice arrangement. This one, although still fairly large, is again fully enclosed. There's the two track terminals. What have we got? Darstan, 5k ohm. And there's the slot to put your screwdriver in and adjust. This thing much more fully enclosed, and we can adjust that quite comfortably without any risk of either scratching the track or having a short circuit or some dirt getting on the thing. A little bit more protected from the environment. Now let's have a look at one which is a bit wacky. This one, it's a sliding adjustment. So the carbon track is linear, and the adjustment is that you slide the slider up and down. Again, you wouldn't necessarily do this with your fingers if it was a valve circuit. This would be on a printed circuit board. There's a bit of flexible wire there for the wiper connection, and the track is simply a straight piece of carbon, and you slide it back and forth. Nice and simple, straightforward. I suspect a little bit fiddly to adjust if it was being done with a pair of pliers or something like that. I think the rotary form is a bit easier to adjust, but there we go. What do I know? 2 megohms, so 2 million ohms this one. Probably from a valve circuit, looking at that high resistance. Now, what if you wanted to make a more precise adjustment and you wanted to have a bit more control over the the adjustment. This thing is made in England by a company called Colvern. 1971, week 37, 1000 ohm, 10%. So how does that adjust? Well, there's the 3 terminals. There's a screwdriver slot on the end, but this time, if I can get my screwdriver in there, and we start to twiddle that, we'll find that it's not just a single turn, that we get 10 turns, if you're counting, from one end of the track to the other. There's a screw thread inside here, not unlike, in fact, the linear type, except rather than having to simply slide this thing along, we've now got a screw thread, and the screw thread is moving the wiper along the track and back again. So this is, as a 1971 date code on there. Brought it a bit more up to date. I've got a few like that of different types. Here's one, again made in England by Bourns, and named on the top there Trim Pot. That's showing which direction the slider will slide if you turn the screw, and once again we can give that a bit of a twiddle, and normally 10 turns from one end to the other. Sometimes you'll find that when you reach the end they'll click and tell you that they've reached the end of their travel. A little clutch will slip. It's not going to do it, is it? That's more than 10 turns by now, I think. I can feel a slight, yeah, there's a slight change in the resistance, in the friction. So it is slipping, but I can't make it produce a click. Never mind. Now, in our inexorable quest to make things smaller, I've got some smaller ones coming up, so I'll need to move my little platform up a bit so that you can see more clearly, a little bit closer to the lens. And here we have now a smaller example of a 10-turn pot. This one, there's the one we had a moment ago. This one is a much more modern item, but again it's made by, if I can get that to catch the light, it's made by Bourns. So it's the same company, it's the same blue in fact as this one, made by Bourns. And the same idea of having a symbol on the bottom there to tell you which direction, CW clockwise, and so you can tell which way it's going to go if you turn it, and it's going to need a smaller screwdriver, isn't it? That is actually, I'm just going to make it, so if you turn, oh, just going to make it, he says. There we go. We can turn that. That's probably a gearing arrangement, a kind of worm gear, so it's probably a rotary track, and this thing is turning a worm gear that turns the rotary part of the pot. It's all sealed up, we can't do anything much with that to see how it works inside, unfortunately. This one is the same colour. Is it the same make? Get this darn thing, there it goes. Bourns again, so there are also another popular manufacturer. It's got another CW to say which end of it is which. You can work out which way you turn it to which way the slider goes. Made in Costa Rica, and again I can simply turn the dial there. So maybe the internal track of this is the same as the one we just seen with the 10-turn arrangement, but it hasn't got the 10-turn gearing. It simply has a direct turn the dial there. 501 is probably the value. That I think is 500 ohms, so it's 50 and 10. Potted on the back for printed circuit mounting, which some of these other ones were also PC mounting, others were more intended for tag strips or something. Here's an interesting one. This is a preset resistor, 2.2K. Can't make out a maker's name on that. But that's actually, I think, exactly the same size as a TO5 transistor. In a little metal can with a little screwdriver slot in there again. That does require a smaller screwdriver or trim tool. So this is meant to be the same size, I would say, as a TO5 transistor. So we're bringing the size down the whole time here. Again, another one which is smaller still. Getting hard to get these to come into focus on the camera, but we'll give it a go. There we have 102, so that is I think a 1K, and again I need a smaller screwdriver or trim tool for this one, I think. Oh no, there we go, that just turns. We're making these things much smaller if we compare it to the size of the original. Here's that green one with the knob on the top. We've got the size way down, and I've got one final tiddler. There it is, a little tiny preset with, again, 501, I think that's 500 ohms. Really little tiny thing. Same blue plastic, maybe that's a Bourns again. Same 3 terminals. All these having the same function, achieving the same end goal of a variable or adjustable resistor, but with different sizes and different constructions. This one, again marked with direction. It has wires coming out, so you're meant to solder those wires to your circuit, and then it has bolt holes. You can bolt it down, so you branded circuit trim by LRC, 10K, 10 turn adjustment again on the end there. Oh, these are getting quite fiddly to get the screwdriver into, but there it goes. Looks again like it's got a worm gear arrangement and a circular track, but this one intended to be bolted down somehow, maybe bolted down in a row of these things with all the screwdriver slots visible, and then the wires going off to the circuit. So there we have a reasonable selection of adjustable and variable resistors for trimming your